Okay, here in this video we're going to look at the sine, cosine, and tangent ratios, variables for side lengths. So when we start looking at the sine, cosine, and tangent ratios, we're really doing some trigonometry. And so, you know, in this class, you're just really getting into the introduction of trig. So trigonometry really translates to triangle measure, which when we talk about triangles here for trig, we're referring to right triangles. So when we have a right triangle, what that means is there's got to be a 90-degree or right angle in the triangle. So trig and these ratios, sine, cosine, and tangent that I'm going to show you apply to right triangles that have a 90-degree or right angle in them. Every right triangle has a hypotenuse that is always opposite of that 90-degree angle. It's the longest side of the right triangle. And then the other sides are called legs of a right triangle. So that is a leg of a right triangle, and that is a leg of a right triangle. Okay. Now, of course, there's a few other angles involved here besides that 90-degree angle, and these angles are always going to be acute angles, or less than 90 degrees. And when we do trig, we usually designate one of those angles, and I'm going to just use this symbol, which looks like a zero with a line through it. That's called like a theta, the Greek letter theta. That's usually the variable we use in trig for an angle measurement that we don't know. But once you identify one of these two acute angles, this is called like our reference angle. So when you have a reference angle, the sides of the right triangle have special names. So just so that we can declutter this picture, let's draw another right triangle. Okay, same setup. I'm going to use the letter H for the hypotenuse. Okay, so H for hypotenuse. And if I have my reference angle theta over here, now these legs have very specific names. You'll notice this side of the right triangle is opposite or across from this reference angle, so this side would be called the opposite. And the remaining side that's right next to the reference angle is called the adjacent. Adjacent is another way of saying next to, right? If you're adjacent to somebody, you're next to them. So we have a hypotenuse, the opposite, and adjacent. And then oftentimes, instead of using the whole word opposite, we might just say O, and instead of adjacent, we can say side A. Now, trig, or trigonometry, has ratios of various sides based on the reference angle you're looking at. The first trig ratio is the sine ratio, which we write as sin, short for sine. It's not sin, it's sine. And then if we were taking the sine of the angle, so when you do a trig ratio, you always put the reference angle in here. And that's equal to a ratio of the opposite side to the hypotenuse. That's all sine is. So the sine of this angle is just whatever this length is, the opposite, over the hypotenuse. Cosine is written cos for short of cosine. So the cosine of theta is the adjacent side over the hypotenuse. And the last trig function we're going to talk about in this video is the tangent one, and I should have just written tan, short for tangent. the tangent of theta is equal to the opposite over the adjacent. So it's the opposite side over the adjacent side. Now there's a short phrase that I'm sure almost every math teacher uses across the country to help you remember these three trig ratios, and that phrase is SOH, S-O-H, ka, and toa, so ka toa, so that you can remember sine is opposite over hypotenuse, so S-O-H, so. Cosine is the adjacent over hypotenuse, so C-A-H, ka. And then toa really is tangent, is the opposite over the adjacent. So if you remember so, ka, toa, you probably will have these memorized. Now, let me show you an example of this applied. If I gave you a right triangle, again, this is not the greatest sketch in the world, but as long as we have our right angle here. And now I'm going to label my reference angle up here, just to kind of switch it up on you. Now, this is my 90, and so the first thing that I do every time I do a trig problem, if I have my 90 here, I automatically will put like an H across from it. I always know that's the hypotenuse. The sides that you might make a mistake on are the two legs and which one is the adjacent and the opposite. Now remember, in this example, the opposite was over here, but that was because the reference angle was marked over here. Now in this problem, my reference angle is here, not over on this side, but my reference angle is here. So the opposite of that reference angle is now over here. This is going to be my O. So if it was over here, my opposite side would be on this side. The adjacent and the opposite sides can flip-flop depending on which of the two acute angles you're using as your reference angle. So since I'm using this, opposite side is over here. That means the adjacent side next to that angle is over here. That would be my A. So I always like to put the H first. The hypotenuse is the easiest. The next easiest side for me is always to label the opposite, and then the remaining side would be the adjacent. Okay. I would like you to also label the variables for these sides as follows. So it would be F here for the hypotenuse, E, and D. So Alex is only going to give you like the green picture, right? And I labeled the red A, H, and O to help me with the problem. And so all you're going to need to do is figure out what the sine of x is, the cosine of x is, and the tangent of x is. Now sine, if you remember, is just opposite over hypotenuse. So in this problem, my opposite is over here, which means it's E. So that's my opposite, and hypotenuse, H, is the letter F. So if I was doing opposite over hypotenuse over H, it's really the side E over F. For cosine, I remember that's ka. It's going to be A over H. So the adjacent side is the letter D. That's the side D. And the hypotenuse is still F. This would be D over F. So just to be clear, sine of x would be E over F. Cosine of x is D over F. And then tangent of x, that's toa, right? That's going to be the opposite over the adjacent, O over H. In this problem, the opposite is E over the adjacent D. So these would be my final answers for finding the sine, cosine, and tangent. I hope this helps you guys out. Thanks for watching.